This program is brought to you with support from the U.S. EPA. We're here to present the EFC Network podcast. The Environmental Finance Center Network is a partnership of 12 centers serving 10 EPA regions. The EFCN provides training and technical assistance to small water and wastewater systems. This podcast series has been designed to help system personnel improve technical, managerial, and financial capacity of the utilities and communities they serve.
Hi, everyone. I'd like to introduce myself. I'm Heather Himmelberger. I'm the director of the Southwest Environmental Finance Center, located at the University of New Mexico. And with me today is George Williams and Paul Crocker from an organization called Reliability X. And we're going to have a conversation regarding reliability, what it is and what it means for you. And I'm going to have them introduce themselves a little bit more fully a bit into the podcast. But we're going to jump right into the idea of reliability. So, George, reliability is something you've worked on for years, but many of our listeners might not understand what reliability is and why it's important. Can you share what reliability means to you and why you think it's important?
Absolutely. So for me personally, reliability is a consistency that our assets perform at, right? We spend an awful lot of money on capital assets, installation and designing them, and we want them to operate reliably. And so reliability is really all of the actions necessary to keep us confident that when we need them, they're going to run appropriately.
Great. And can you talk a bit about your background? How did you come to reliability and why did you choose to stay in this field?
Yeah, just really briefly, I'm an inner city kid that went to a VOTEC high school, and maintenance has been in my blood from day one. And throughout high school, I worked in a garage for a company my father worked for. And so I've been in maintenance essentially my whole career. I spent a large portion of that working for Bristol Myers Squibb Pharmaceuticals and specifically within the maintenance realm there, and then gradually attained my master's degree in maintenance and reliability engineering and took on exceedingly expansive roles up to the point of being responsible for it globally for them.
And Paul, you've spent a lot of time working in maintenance and a water utility prior to your time here at Reliability X. And your journey is one in which you learned a lot from doing. Can you tell us a bit about your journey into water treatment and then how that journey led you into reliability?
Yeah. So I don't know. I got into drinking water sort of outside the country doing a project, and it got me interested because I was already working at a utility in the drinking water division, and so I joined the water treatment plant originally as an operator for 2 years. And then they had a job open up in maintenance, and they needed someone that had sort of an IT background that would be able to help them stand up IBM's Maximo CMMS system. They had reported all the plant's location and asset hierarchy, but that was all that was built in the system when I got it. So I took the job of maintenance supervisor, and I learned pretty quick that when something breaks, it causes a lot of chaos in operations. And then people start asking me a lot of questions I can't answer. Why did it break? Or like, why didn't we know that was coming? Like, well, you mean when that big 500 horsepower motor and high service started vibrating the floor? Like, why didn't we have any heads up on that? Like, I didn't have any answers. And going to the sort of water conferences wasn't really helping. They were talking more about treatment and distribution systems and things that weren't really maintenance related. So I was like, what organizations can I find where I can learn more about this stuff? And then I came across SMRP, the Society for Maintenance and Reliability Professionals, and International Maintenance Conference and the Reliability Conference. And I started attending those conferences. And that's where I really learned a lot about that. So then there's these predictive, I actually call them sort of condition assessment technologies like vibration analysis, soil analysis, where you can do some things to the machines without being destructive or taking them apart to find out their operating condition. And so you're not startled when a pump starts, shaking and vibrating in the building, and, you got some heads up that something's going to happen. So to sort of stave off those, oh, damn, why did that motor just do that? I kind of had to do a lot of education so I could do better and not have those things happen.
Great. And I know you've had some successes at your water utility. Can you share some stories with us of reliability in action, just some of the simple things that you did to sort of help particular assets in your system perform better?
Yeah, a lot of those were around the big motors. We had a lot of vertical turbine pumps with medium voltage motors. That's around 4,180 volt motors on them, 500 horsepower and up. And those had oil baths for the lower and upper bearings. And so one of the things, condition monitoring was to take a look at the oil in those to get a gauge of what was happening with the lubricant and the bearings. And that's sort of one of the easy ones. I just really started out with oil analysis initially. That was kind of easy because it's cheap. I could send it off to a lab and be confident in the results I was getting back, and I can compare those because they always kept the monitoring point, so you could compare this sample to the last sample and the one before that. And if you did an oil change, you could see what the new sample was. So it was really helpful initially getting some success in, hey, bosses, we need to do this. And I didn't have a tool budget. I think when I started out in maintenance, I had $1,000 line item for budget for the year. And they weren't going to the status quo was, well, we've always done it this way for the last 100 years. Why do we need to change now? And I'm like, well, why do you pumps just starting to shake, and that's your means of knowing when to do maintenance on it, and then you freak out, when it's $200,000 or $300,000, whatever to replace one of our big pumps, and $20,000 for a motor. I mean, wouldn't you like some heads up when that sort of thing is going to happen? Because they're going to fail at some point, but it's the knowing when that's going to happen that's really important, and you can't do that without knowing what's going on with your assets.
You mean $1,000 budget isn't enough for all the things you have to do?
I got that up quite a bit before I left, but yeah, $1,000 is all I had initially, and I thought that was more than enough.
So water and wastewater utilities have a mix of mechanical and passive assets. So mechanical assets are things that we can think about like pumps and valves that turn and mechanical rakes, grit removal, aeration equipment, clarifier arms, treatment units of some types, chlorinator mixtures, and those types of things. And then we have our major passive assets, which of course are our pipes in the ground that just kind of sit there and do their thing. And then maybe a storage tank that mostly is just a big vessel to hold water, and we have other items with moving parts. So for both of you, is reliability applicable to just our mechanical assets? Or can we use it on both of our assets, mechanical assets and passive assets?
The short answer is both. But Paul, you wanted to give more detail?
Yeah, you can definitely use it on both. There's different things that you can do. You can't use sort of like oil analysis on a pipe, but you can do thickness testing. You can do camera sort of testing. There's some pigs you can use that take conductivity measurements, so you can check wall thickness, on buried pipeline and stuff. So there's all kinds of things you can do on both passive and sort of active assets.
Do you see reliability as more important for mechanical or passive, or do you see any difference between those? Like, would it be more important to apply it to your mechanical assets than your passive, or do you see it as equally important for both types of assets?
I think equally important.
Yeah, it's a holistic understanding of risk management, right? It's really, how do you manage the risk? And in today's world, whether you're a large municipality or a small municipality, you're still managing risk. You're managing, should I know about these potential issues ahead of time? Or am I going to just absorb the risk? And most municipalities would probably like to know what risks exist and what investment is necessary to mitigate those risks outside of just more redundancy. And what spare parts are most likely to fail? What should we stock in a storeroom? Because that's money. It's money sitting in the room. And it shouldn't be acceptable to just stock everything. And it probably is not. And so a more stringent approach to understanding what money should be sitting there for risk mitigation and what approaches are critical to that particular municipality is what reliability is all about. It's about managing risk.
And I guess you've probably seen the spare part end of things change a bit through COVID? Because I know I've talked to a lot of utilities who have seen a huge change in the lead time for even simple assets, hydrants and valves and meters and that type of thing, where the manufacturing processes were kind of disrupted and it was taking a really long time. So I'm imagining maybe things even changed a bit because of COVID, and what spare parts you keep on shelves and that sort of thing may have been affected by that.
Yeah. And even post COVID, because of the skilled trades gaps, those manufacturing plants are having a difficulty still maintaining a decent lead time. And now it's not just a matter of we're not allowed in the plant, and so we can't produce, and our raw materials are taking longer to get. There's this trickle down effect of the folks that have retired early and took early retirements. And so this, as I've heard many other people say, the silver tsunami of people leaving the industry and being replaced with folks that either lack skill sets or not being able to replace those positions at all because folks just aren't willing to take them has impacted a massive trickle down effect from just raw minerals down to finished goods. And so organizations have to prepare for that. Your lead times are not going to be the same. And so the criticality you thought existed 4 years ago, even if you've gone through that process, is different today than it was.
So would you recommend that, water and wastewater utilities maybe take a look at what they currently have in their spare parts inventory and maybe see if they need to make some adjustments of having more of one thing and less of another, those types of things?
Yeah, no doubt. There's math behind it, right? Understanding lead time, criticality, daily demand over the course of X amount of time, 1 year, 2 year, whatever it may be, all plays into whether or not it should be on the shelf and how much of it you should have on the shelf, as well as the cost to place an order. All those things kind of come into play. But yeah, if you're looking to mitigate that risk and not spend hours and hours on eBay, then yes, assessing your spare part inventory is a easy way to make an improvement. It's not going to stop the failure, but it is going to minimize the length of time that you're at risk because you're on your last leg of redundancy.
And we can talk a bit more maybe about risk, just to make sure our listeners know what we're talking about. And typically when I think of risk, we're looking at what the likelihood of an asset failing is, and how high that likelihood is affects its risk, as well as the consequence. So if the asset does fail, is that going to cause a serious problem? So those assets that are likely to fail and will cause a really serious consequence are going to be your highest risk or highest criticality, and those that aren't likely to fail and won't cause a problem are your lower risk. Do you think of risk in any different way in your work, or is that pretty similar to how you think about it?
There's a few different categories of risk, right? There's the risk to the operation, the ability to continue to operate. And most municipalities have ways to maneuver flow so that that's less of an issue, where they have redundancy within their assets. But then there's the risk of cost, and what's the cost risk? Because if we'll just say a bearing inside a pump fouls, it is likely to create other ancillary damage. We're going to need to get a new shaft. There's other things that cost money. In the use of the technologies that Paul was speaking of earlier, that ahead of time and can take the asset down at the most convenient time for the operation, not that it's ever convenient, and replace those parts and order them ahead of time. And so you mitigate additional costs. So there's a cost risk. You then have, what other damage when I have to mitigate flow and I have to maneuver flow in order to operate, does that create other problems upstream or downstream in terms of how my pumps operate and friction rates and how that impacts the operation and erosion inside the plant itself? And so there are risks associated with having to divert flow. And then there are safety concerns and risks associated with safety concerns, potentially depending on what type of asset it is and how it fouls. So there are certainly different categories of risk that have to be managed from a reliability perspective.
And Paul, I was going to ask you, one of the things that I've observed in the water industry, and I mean the broad water industry of drinking water, wastewater, stormwater, is that people within the utility, the operators, the maintenance staff, maybe even some of the managers understand a bit about the risk, and they've experienced it. They've experienced a failure. So they've seen what happens, when a catastrophic failure occurs, big pipe breaks in the middle of a busy street. So they understand the risk, but often it's hard to pass that risk up to the leadership and have the leadership understand what the risks are as well. So I wondered if you had ever experienced that, where it's maybe difficult to explain to upper management what risk is and push the idea of understanding risk up to the decision makers who get to choose your $1,000 budget.
I think the leadership of my utility understood that risk pretty well. I think they were always looking at it. They were always in touch with the engineering firm that built the plant. That engineering firm loved to bring customers from around the world to the plant because it was one of their newer all-inclusive, the plant's all in one site, not a bunch of different buildings that operators have to travel to. So I think they always understood that pretty well. We did exercises with the city around risk for Clean Air Act because we had chlorine and ammonia on site. So we always had to look at those things. I think, at least in my utility, we understood that pretty well. I wouldn't say that was a difficult thing to talk to them about. The struggle I had was in reliability. And I think for them, they always understood reliability as redundancy. And they're a little bit different.
It's an interesting topic, though, Heather. Like you mentioned, what are you going to do when they tell you this is your budget? The assets could care less of what you would like the budget to be. You will spend precisely what it took to operate, whether they foul or they run well. So you can either invest to run them well or suffer the consequences of spend if the risk comes to fruition. And it's the onus of the maintenance department and the operations department to be able to articulate that risk and articulate the necessity to take care of the asset appropriately in order for it to perform reliably. The difference between a Model T Ford that's rotting in the earth and one that's still on the road is not how well the mechanic did when it broke down in an emergency. It's how well it was taken care of in daily operation and routine maintenance. And so those things are critical to mitigate the risk.
Great. So what advice would you give to a water or wastewater system who says, okay, I hear you talking about reliability. Maybe I hadn't really thought about it before, but now I really want to take some steps and, get more into reliability, want to figure out how to start my reliability journey. What advice would you give them regarding how to start a reliability journey? Is there one simple thing they could do to take the first steps? What would you say would be the best investment of their time to get started down this path?
I would say there's two things they have to do. Number one is to understand their business. Not that they don't understand it today, but it's a requirement to understand risk. What makes the municipality operate? What are its critical goals? Understand the business operation of the municipality. And the second is to educate yourself on what maintenance and reliability is all about, what exists outside, and what practices exist so that you can then best understand which of those practices can add value to the business and how your business operates. For me, they're the two biggest keys. It's not really go implement this. It's educate yourself so you know what to apply where.
And we've talked about a lot of things today. Is there anything that we haven't talked about that you would like to share with our listeners?
So for me, we're an empowerment company. What we do is educate and empower folks to be able to be the voice for the asset. And so I just encourage anybody, whether they're looking at our website or anywhere else, to educate themselves on what they can achieve by focusing on maintenance and reliability, and understanding the care of their assets is a crucial part of what they do.
How about you, Paul?
Yeah, mine sort of revolves around the condition monitoring piece, because if you know the condition of your assets, and you've been tracking that and trending that, then you kind of have an idea when they're going to fail. And if you've got an idea when they're going to fail, it's something, especially if there's a lead time in that before it gets to a point where it just isn't going to run anymore. that you can set aside some budget to deal with it. If things happen all of a sudden and then it's emergency, well, then that's causes all kinds of problems, financially too. So a lot of that's in the risk to money. Something's coming ahead of time, and you can sort of budget for it. Like we had a big 500 horsepower motor that took from the point when we first saw it having some bearing issues to when we finally pulled it was 2.5 years later. And we were able to run that for 2.5 years and get it in the budget and get it repaired, with a line item for the next year's budget on a capital deal instead of an O&M expense because we knew about it. And then it wasn't a disruption operation. It wasn't a disruption of safety. Everything got planned out well in advance. It was just life is so much better when you know what's going on with your assets and you don't wait for them to start screaming at you and blowing up or catching on fire or letting smoke out, however the particular asset fails.
Would you say it's cheaper to do repairs and fixes in a planned manner versus in a emergency manner where it just fails, sort of you kind of let it go and it fails and you have to do it as an emergency, versus what you're talking about where you kind of plan that you're going to limp it along until you have the money? Would you say it's more expensive to do that emergency versus the planned variety?
It's always more expensive for the emergency. And then there's also the safety factor for people. People generally get injured more when things haven't been planned out from a safety aspect because everybody wants to be that hero that gets it back online. And I've seen that a lot over the years. So
that's a true statistic, Paul. Four times more likely, right? 4 times more likely to be injured.
Oh, wow.
Emergency work order than a planned work order. That's documented numbers.
That's interesting because I always think of just the cost side of things, but for an operator or manager or anybody working, maintenance person or working in a plant, they're very dangerous places to begin with. And to hear that, safety is a more important aspect even than the money, because we want to keep our people safe and healthy. We don't want them hurt. So that's a really good reason. If the money's not enough, safety's another.
I'll put it this way: a blower and an extension cord, maybe $150, and a MSA air sampler, maybe $200 or $300 to know if there's oxygen in a manhole, versus sending somebody in a manhole to go do something. He climbs down the ladder and no oxygen or hydrogen sulfide or whatever, and dies. That cost is gigantic. So it's a lot better if you're safe and do things in a planned matter than trying to react to things and be the hero.
That's great. So I think that's all we have time for today, but I really appreciate George and Paul being with us today and encourage all of you listeners out there to consider reliability. One of the things Paul and I have talked about, and Paul brought it up today, is don't get caught up in because we've done it all. We've always done it this way. That's the way we have to do it. You can question things. You can look for data. You can look for experiences. You can reach out to other utilities and find better, more efficient ways of doing things and protect yourself in the process. So if no other reason makes you want to do it, maybe the safety aspect can make you want to do it, that you want to plan your actions instead of doing on emergencies to keep you safe. So I greatly want to thank George and Paul for being here today and for being willing to share their time and their expertise with us. And thank you all for listening.
Thank you to all our listeners for tuning into this episode of the EFC Network Podcast, brought to you with support from the U.S. EPA. Be sure to stay tuned for future EFC Network podcast episodes.